All right. So let's get started. So my name is Siddiq Sheikh. Okay, I'll be starting the presentation. We'll go through the DevSecOps process. The different topics. We're going to touch base all of that, and then uh, we'll have a demo session, which my colleague Saeed will be presenting. Okay, and then we'll have a Q&A session where we'll answer all your questions. Meanwhile, if you have any questions, you can still go ahead and type it in the chat, and we'll take up all of that in the end. And I'll appreciate if everyone just make sure they are on mute so that we don't have any background noise coming into the session. All right, so let's get started with the session. So DevSecOps overview. Okay, let's look at what we have in the agenda for today. We'll start with learning about what is DevSecOps. Okay, how it works, where DevSecOps can help you, and what are the challenges that we face, and why do you need security as part of your DevOps flow, as part of your DevOps environment. And then we'll also look at how you can integrate security into your DevOps process, which you already have in your organization. And we'll also look at different tools that are available to integrate security as part of your DevSecOps. And yeah, just to give you a heads up, it will be focused more on DevSec, and that's why we have Apollinaire as well here in the session who can put some light on that as well. So let's get started with the DevSecOps overview. So in a common DevOps flow, you have all the stages which are streamlined. You have everything automated, starting from the commit stage to build to deployment and the testing, and everything is streamlined. You already have the best methodologies and tools and technologies as part of your DevOps process in your organization. So everything is streamlined. Now, when it comes to the DevOps flow, okay, so you have the developers committing the changes, right, and then you have the automated tests that are performed for the changes that has been committed, and then you have the build stage where the release is built. Once the test is successful, you go ahead and have the image built, and those images are then deployed in a test environment, in a UAT environment, and then you go ahead and perform more tests to make sure that you're releasing a stable software. Then you perform test. Once the test is successful, then you go ahead and deploy it in the production environment. Now, all of these are streamlined, and the process is working fine in your organization. Okay, so far so good. Now, when it comes to security, the security tests are performed in the end, right? Now, when you perform this in the end, okay, you get to know about the issues and the vulnerabilities, all of that, at the end after you deploy it in the production. Okay, so that becomes more like a operational teams thing to go ahead and perform the security test, and then if any security vulnerabilities are found, then you again go back to the first stage where you again have to go ahead and fix those vulnerabilities and security issues that you have found. So that's not the right approach. Okay, what we say when it comes to DevSecOps is to go ahead and integrate security at every stage of your DevOps flow, and not as a process to be performed in the end. Okay, and that's how you can go ahead and make sure that you don't find security vulnerabilities and issues post deployment into your production. You go ahead and find the security vulnerabilities and security issues right in the DevOps process itself during the software development lifecycle itself. Okay, so what are the challenges when it comes to performing security during the development stage itself? So when it comes to developers, they are focused on delivering business requirements, right? And then they are not really like security guys, right? They don't know how to find security issues or security vulnerabilities in the code that they're writing, in the application that they're developing, right? So they need help in identifying the security risks and security vulnerabilities. And when it comes to security testing, it may take days or weeks to go ahead and complete if you are performing manual, security testing, right? So you need some sort of tool to go ahead and automate that for you, okay? And tell you what are the security vulnerabilities and how to fix them, right? So when it comes to security team, uh, they need to first understand the modern technologies, especially when it comes to a DevOps uh, process that has been, set up based on your cloud environment, for example, right? So they need to know, the security team should know about the public cloud platform, be it Azure, AWS, um, Google, and so on. Okay, and they need to understand how Kubernetes works. If your environment is set up in Kubernetes and your application is deployed in Kubernetes, and the DevOps is tightly integrated with that, right? So they need to understand how to, do the security vulnerability testing for such an environment. And then when it comes to security testing tools, if you have legacy security testing tools, okay, then they were developed long before, and those tools may not find the security vulnerabilities in your application, or it may not get integrated with your DevOps flow at all. So so you need to have the latest tools which can integrate with your DevOps flow, and thereby building a DevSecOps process in your organization. So you may need new tools depending on which you're already using, right? Um, Now, when it comes to security tests, okay, it may find hundreds of vulnerabilities, right? And it could range from critical to high to low, right? And every single time you find security vulnerabilities, then you have to go ahead and create new versions, okay? And again, the same CI/CD pipeline have to be followed. So instead of this is when you perform security tests at the end, right? And that's when you release app version 1, and then you go back to your table, and then you perform, and then go and again develop version 1.1, version 1.2, version 1.3, so on and so forth. So, and then again, this will again increase the time required to release all these versions, because you have to fix all of these security vulnerabilities every single time, right? If you perform the security test in the end, okay. Now, and then this creates a bottleneck as well, right? Like you have to perform the security testing, and then you have to go ahead and create next versions, like it's app version 1, but still you have to, just to fix that security versions, again you have to build another version as app version 1, app version 2. So you have multiple versions of your software being released, and then you have to deploy that in the production again and again, right? And this basically delays the release of your software, and thereby causing bad customer experience in the end, or the user experience who are using those applications. Okay, so to how can we go and solve these challenges, right? So that's where security comes in, which is integrated within your DevOps flow, where you have planning stage. From there you go into code, where you go and develop the code and commit the code, and then you go and build the image, you go ahead and test it, then you go and release it, and you go and deploy it in the production. And then that's where the operation teams comes in picture. They go and do the monitoring and performance monitoring and everything, security monitoring. And then again, based on the feedback, based on all the details that is collected in terms of application performance and security, then you come back to the planning stage again to go ahead and address all of that in version 2. Right, so that's where security comes in picture, so that it's integrated in every stage of this flow, and ensure that this application that you're releasing is of the best quality. It does not have any security loopholes. It does not have any security vulnerabilities, and you can release it with confidence. Now, the important factor here is that you have a DevOps flow which is streamlined, which is fast. So you don't want security to go ahead and impact that. Okay, you want to make sure that this still streamlined, and it does not cause any delay. Okay, and that's why we say integrating security into DevOps, it becomes part of the same flow and does not add to the delay in releasing the software. Okay, so this is where we were looking at the DevOps flow earlier, where the security testing was on the right. right in the end after deployment to production. When it comes to integrating the security into DevOps, you go ahead and shift the security from the right to the left. Okay, by that I mean you have security checks happening, security scans happening at the end of every stage of your DevOps flow. You have the developers committing the changes, you perform the security scan. Go ahead and scan the code, you find security vulnerabilities, security issues, you go ahead and fix it right there before moving on to the next stage, right? And then you go and perform the automated testing. Again, you perform the security scan, you find vulnerabilities, you fix it in that stage. You move to build stage, you have the image built, then you again perform security scan. Okay, and then you have the image deployed to your test environment, your UAT environment, you again perform security scan, right? And then you perform the automated test before the actual production to deployment, you again perform the security scan. So this way you can go ahead and make sure that, you have security integrated right into your DevOps flow, and you are releasing a software which does not have security vulnerabilities, and thereby you can avoid the delays that happens in terms of fixing the security vulnerabilities later on post release. And then you can also avoid creating like version 1.1, 1.2, 1.3, and so on and so forth. Okay. So moving on, why DevSecOps and what are the benefits of DevSecOps? Starting with vulnerable third-party libraries. Okay, so when it comes to building an application, building code, of course, developers, they use third-party libraries as part of it. Okay, now they may not know about the security vulnerabilities of third-party libraries, right? So that's where the FortiDevSec or similar tools that they come in picture. They go and do the security scan, and they perform the scan, and they find out if there are some third-party libraries like open source libraries which have some vulnerabilities in it that needs to be fixed before you go ahead and release the software and run the application in the production. So this is just image of how it finds the security vulnerability, and it tells you the impact of those vulnerabilities, and how you can go ahead and fix them. Next up is licensing compliance. Now, when it comes to any third party or software that you're using, or any open source libraries that you're using, or libraries that you're integrating within your code. Okay, let's say, for example, if you have GPL license, GPL version 3.0 or 2.0 as part of your code, then again that's a violation of company policies, right? So it should not be part of your application. So that way, the security scan will go ahead and tell you that this is there as part of your application. Please, make sure that you don't have any such GPL as part of your code. Okay, go ahead and fix those licensing issues before you go ahead and release the software. Okay. And then when it comes to sensitive data leaks, okay, so you may be, the developer, when he's writing the code, he may be storing the passwords or private keys or API keys as part of the code itself, which is not the right practice, right? So that's where the security testing comes in picture, which scans and tells you that what kind of sensitive information is stored in your code, and what's the impact, what's the severity. Okay, and it will tell you exactly which line of the code that particular information is stored in. Okay, and you can go ahead and revisit that particular line of code, and then make sure that it's not there. You use like, for example, in cloud services, be it Azure, AWS, or GCP, we have different services where you can go to store your sensitive information and perform API calls from your application to fetch that information, and then access other services. So these information like passwords, private keys, API keys should not be stored inside the code. Okay, so it should be something which should be stored in for example, Azure Key Vault, okay, or AWS Secret Store. Okay, so that's where it should be stored in, and not inside as part of the application. Okay, so this security scan can go ahead and tell you exactly that. Next up is vulnerable Docker image. Okay, so you have a image built, you have a Docker image, which you can go ahead and deploy. Then this security scan should be performed on that image as well. It could have um, some problem with within the image. Okay, and it can go and scan that. It can tell you, what are the dependencies which has been tested, and what are the issues that has been found, how many vulnerabilities are there. Um, and then it will also tell you in terms of severity, now like critical, high, medium, and low vulnerabilities that has been found in that image. Next up is Kubernetes misconfiguration. Okay, this is again an important stage where you have to make sure that you perform the scan and you see if there is any misconfiguration as part of it, and go ahead and ensure that you go ahead and fix them before it goes into your production environment. All right. And then the last one is larger attack surface of your modern apps. Okay, now the uh, security testing, like I said, it could take days or weeks to complete, right? So depending on like for example, you're using microservices APIs, container images, okay. You have your environment in public cloud platforms. You're using Kubernetes, okay. So there's a large attack surface, okay, when it comes to modern apps, okay, and that's where security testing tool comes in picture, which can work with all of these, modern apps, okay, where you're using microservices APIs, container images, any public cloud platform, be it Azure, AWS, GCP, and so on, and if you're using Kubernetes, all of the security testing tool that we're going to talk about can take care of. It can go and perform security scans, and it can find vulnerabilities, within this whole surface of modern apps. Okay. Okay, now talking about FortiDevSec tools. Okay, so FortiDevSec can go and perform automatic continuous application security testing. What are the different testing it can perform? Okay, starting with SAST, which is static codes. Okay, and then it can perform DAS, which is dynamic code, and then it can go and do security testing for secrets as well. And then now, when it comes to the FortiDevSec, okay, so there is single YAML configuration file, okay, for all the security scan types, and then there are different scanners that are available, which you can go and deploy. And for every stage and for different environments, there are different scanners available depending on the programming language, the platform that the application has been built, and you can go and deploy those scanners for your environment, and it can go ahead and perform these different types of testing for your environment. So just like I said, it will automatically go ahead and detect what type of scanners are required for your application. So depending on the programming language, depending on the frameworks, FortiDevSec scanner can automatically get deployed for that particular environment. Okay, and what are the different supported programming languages? For the static testing is C, C++, Java, Golang, JavaScript, PHP, and Python. Okay. And then when it comes to scanners, okay, so the FortiDevSec scanners are deployed as Docker images, okay, and it has literally no prerequisites, and it can run that, be it your be it you have on-premise environment or be it in the cloud. You can go and deploy these Docker images in on-premise or cloud, and it can go ahead and perform the security scan and testing from that environment. Okay, and like we have been talking about easy integration, with your existing CI/CD DevOps pipeline. So FortiDevSec, being a DevSecOps tool, can go ahead and easily integrate, as part of your CI/CD DevOps pipeline. Now, how does the FortiDevSec console looks like, the dashboard looks like? So this is where you can see a summary of all your applications that you have. Let's say, for example, you have 9 applications, right? So it will show you all these applications listed here, and then it will show you the number of vulnerabilities you have for each application. And then if you click on it further, it will show you about those vulnerabilities in terms of high, low, medium, and so on. And it will also tell you about the risk rating of each applications. Okay, and what kind of vulnerabilities have been found in terms of static, dynamic, SCA, and so on. Okay. Moving on, this is another view of the dashboard where, let's say, you're going to Rails Goat app application. Here you can see the risk rating, the number of vulnerabilities, and then you can see the different scans that was performed and vulnerabilities in each of those scans. And then here you can see the different filters that are available, because you may have hundreds of vulnerabilities after the scan, right? So how do you go ahead and go through all of those vulnerabilities? You can use these filters, vulnerability filters, for example, where you can choose to go with, risk rating and go for critical, high, medium, depending on which ones you want to fix first. And then you can select the category of the scan, and you can also choose the status. For example, some scans has already been reviewed, already been fixed, right? So you can go ahead and choose that status accordingly. You found new vulnerabilities, you want to go through that, then just choose that status, and you have it streamlined or narrowed down to new vulnerabilities. Okay, and then every vulnerability that you go through, you go ahead and review them, and then you can go ahead and mark them, as reviewed, or is in still in review. You're still trying to find how to fix it, or it's confirmed. Okay, or you can just mark it once it's fixed. You can mark it as fixed. Okay, or let's say it's a false positive. It's not really a security vulnerability. You can mark that as false positive. And risk accepted is where it's a risk, but you still want to continue with it. Then you go and mark it as risk accepted. Okay, and then this view talks about the details of the vulnerability, right? So when you click on a particular vulnerability, like possible SQL injection, okay, so it will tell you, about the first appearance, last appearance, which application that vulnerability is in, okay, what's the line of code where you can see that vulnerability, okay, which file is it, what's the severity, okay, and then more information you can see in CWE about that particular vulnerability. This is another vulnerability for which you can see the information. For example, you can see path traversal, right? So here it will tell you which code snippet it is in. For this image, it says it's dynamic scanner. There is no code to display. Okay, and then it will tell you that this is the URL where you can, which has the path traversal, and then it gives you description of what that impact will be of this vulnerability in your code, in your application. Okay. And then next up we have DevSecOps with GitHub security. Okay, so here this is we're talking about another tool which can also perform DevSecOps and get integrated as part of your DevOps pipeline. Okay, GitHub security can also go and perform secret scanning, code scanning, and uh, GitHub dependabot. Okay, this is where you can see the flow of the GitHub security. Okay, so it works with, for example, it authenticates to Azure Active Directory. Okay, then it connects with GitHub code spaces. Okay, and then it makes use of GitHub Actions. Okay, and that's where GitHub security is initiated. And then GitHub Actions is what looks into your, for example, you have your Azure Resource Manager, okay, and you have your templates. You could make use of that. Go ahead and deploy the environment. For example, you deploy an application as an Azure App Service, right? So here is where GitHub will come in picture, and it will go and perform the secret scanning and code scanning and GitHub dependabot. Okay, and then here you can see scan code as it's created. Okay, it's just like if we want it to be integrated as part of the DevOps. The moment the codes are created, the codes are committed, you go ahead and perform the scan of that code for security vulnerabilities. Okay, and this will exactly tell you like what action needs to be taken in terms of security, and go ahead and fix them as part of your security testing, and it will be part of your workflow itself. And then you can see security issues in your, when you perform pull request, okay, as part of your code review process, you can go ahead and, see what are the different issues that are there in terms of, for example, database query built from user control sources. So to tell you, you can go to this particular line 25 in this file, and then you can go ahead and, go ahead and fix that, and prevent such vulnerabilities from being committed into your main application. Okay, and then this view basically talks about how you can look at security vulnerabilities in terms of high priority and exploitable security issues in your code. Okay, and you can see how many are open, how many are closed. You can filter it based on severity and branch. Is it part of the master branch? And what are the vulnerabilities in terms of missing rate limiting or incomplete string escaping or encoding, which file or which code that vulnerability is in, and you can go ahead and make sure that those vulnerabilities that need to be fixed is visible for you. Okay, and then we have you can go ahead and create custom queries to go ahead and find the vulnerabilities as part of your code. Okay, and you can use like you already have code queries available as part of GitHub security, but then you can create custom queries that you think is required, and the existing like 2000 plus code QL queries are not helping you in finding the security vulnerabilities. You can create custom queries as well. Okay. And GitHub security can also be integrated as part of your third-party scanning engines. Okay, and you can go ahead and view results from your security tools that you may be using, and all the security vulnerabilities of different security testings, different security tools can be viewed from a single interface. And you may be creating a separate dashboard for viewing all the vulnerabilities from different security testing from different tools. You can go ahead and export all of them, export the results itself through a single API, and view them from different dashboard. Okay, so that's it from my side. We talked about the DevOps flow. We talked about how we can integrate security as part of the DevOps, and begin a DevSecOps practice. And we looked at the 40 DevSec features, and also about GitHub security. Now for this slide, I'm going to hand over to Apollinaire, who will talk about this slide and Fortinet, FortiDevSec specifically.
Thank you, Sadiq. Thanks for a great explanation on FortiDevSec. And the reason I've chosen this slide is I wanted to contextualize the intention, obviously, once we've developed our code, is to put it in production, to put it to work, right? So ultimately, we want to deploy it in the environment, which is the target environment. And obviously, that's when the real, or the second phase, rather, the security concerns start, right? Because we're sure we've got good code, fantastic. Now we've got to make sure that the traffic which is going through our different cloud environments is going to be secured in a way which is correct. And now, if we're deploying this in a public cloud environment like AWS, like Azure, they do have some security resources. So, for instance, they're very good when it comes to identity and access management. When it comes to network and traffic security, a bit less, and that's where they rely on partners like Fortinet to provide that part of the security. And really what we're doing here is if I move from left to right, I'm not going to give a product description of all the solutions. It really wouldn't make sense. I think we don't have time. But what I do want to highlight is that we are very much into a layered approach when it comes to security, because once a code is deployed and I've got an application working, how am I going to protect that? Well, several layers. The first one, and this is, I think it's fairly obvious for everyone, right? It's about securing the network, and it's about securing the connectivity to my cloud environment. That I'll do with a firewall, and the next generation firewall, which is going to apply antivirus and intrusion protection and intrusion detection, and it's going to do bot control and application control of all these features, which make sure that the bad traffic and the bad guys are kept out. We can also terminate VPN connections and have this deployment, right, this node, as part of an SD-WAN network. Very useful when it comes to digital transformations, as you can imagine. So that's phase one, right? We're securing the network, the entry point. And then the next layer of security is going to be securing the applications, because firewalls do a very good job when it comes to traffic, but when it comes, there are some specific attacks which are targeting applications. And for that, you need a web application firewall, or WAF, right? So that's going to provide us an extra level of security to make sure that we're protecting all the right protocols that are usually used in application servers. We can also put this deployment within a zero trust network. We've got several ways of doing that. We can have some authentication. If I've got users that are connecting directly to a cloud deployment, so they're not tromboning, they're not going on site and then tromboning back over to the cloud, it makes much more sense to do that. So, multi-factor authentication is going to be important. And we can have some agents which allow that connection to be done on the zero trust basis. So it allows users to be authenticated and identified, and only give them access to those parts of the networks that they should be able to access, right? So this is no access by default, and then you grant access as and when justified, right? Which is a much better way of providing security in these environments. When it comes to CI/CD security, Sadiq did a great job to speak about DevSec. I'm not going to go over that again, but what we should do, obviously, is pay a lot of attention to container security. Containers are a special environment. The dynamics in containers are not going to be the same as discrete VMs. The way of deploying security here is going to be different, and for that we have to have a dedicated series of appliances which are able to do that in a virtual manner. Email is a specific application. Earlier on, we were talking about web application firewalls. Email is different. It uses different protocols, and it's got some, let's say, some more specific types of security that we have to apply, and that's why we have different dedicated appliances, virtual appliances for that. Now, once we've done that, we've got a pretty secure environment, but there still can be that Trojan horse, the zero-day threat, the threat which has never been identified before, because the solutions I've described previously rely on databases of known malware, known threats, or known compromised websites. So what do you do if there's a new threat that there's never been seen before? You use a sandbox. The existing or the other security solutions should do a reasonably good job of evaluating whether a file or traffic is malicious. And if in doubt, you can use a sandbox, which is going to emulate a virtual environment where a file, for example, which is suspected of being malware, where that file can be detonated, it can be run, and then that sandbox can observe the behavior of that file to determine whether or not it contains malware. So a sandbox is the special edition that makes sure you've got all your bases covered. Now, when it comes to operations, analytics, monitoring, automation is the name of the game here. What we want to put in place identification and remediation procedures, which allow us to identify if there's been a security breach in our deployments and automatically remediate that. And that we do with tools which allow us to centrally consolidate all the logging from the different security devices and produce reporting. What can happen sometimes is that we can get an attack which is orchestrated across different attack surfaces. And so that attack would be hitting different appliances. To be able to analyze and understand that attack is taking place, we need a tool which is able to take logs from the different security instances and build a real-time picture of the threat as it's unfolding. And that we do with a combination of FortiAnalyzer you can see here in a product called Manager. And then at the end of the day, it's about those more advanced security functionalities. If you've got a SOC, for example, you need some sort of method for collecting the logs from the different devices you're monitoring, the computers and the servers, your switches, your routers. For that, you need a SIM solution. Last but not least, SOAR. SOAR is the icing on the cake in as much as it provides artificial intelligence to analyze the thousands of logs you're going to be receiving at any given point in time, making sense of those to see which are the ones which constitute real threats and which are the ones which are not. But more importantly, being able to apply remediations, so-called playbooks, which allow you to automate the reaction that you're going to have if there's a certain threat or a breach which takes place. So a SOAR, if you like, is a virtual analyst, which is able of making real-time decisions when it sees there's a threat which is coming in, and it could be across multiple types of devices. More importantly, it can make decisions and actually utilize that threat in a manner which allows the operations to continue in a secure way. So that was just a quick update, just to contextualize and give a quick understanding of where the DevSec tool from Fortinet stands within the wider picture of tools which are needed to secure these sort of deployments. Now I can hand over to the next presenter.
Okay, thank you, Apollinaire, and thank you, Sadiq. So I'll continue with demonstrating Forti DevSec tool with Azure DevOps. So let me start by sharing my screen. Okay, so let's assume that I have my application already uploaded to a repository in Azure in Azure DevOps. So this is my application. This is a sample PHP application that is designed to be vulnerable. So it's just for learning and testing how you can do static application security analysis, or in general security scanning of applications. So this is my application already in the repository, and this is how the application looks like. So this is the application. Basically, it's a to-do list application where you, for example, type in a task here and save it. So this is how the application looks like. I can just create tasks here and they appear here in the list. Now, there are a couple of functions. We are not going to dive deeply into how the application works, but you can edit, you can delete, you can, for example, send a reminder of the task by email, and you can download it as a PDF. Anyway, if you look at the source code of the application, you will see, for example, if I go back to Azure DevOps here. So if I look, for example, on one of the files here, like this one, tasks.php, I can see, for example, that input from the user, which is in the form of a forum parameter, so passed in a post request, is used directly to construct a dynamic SQL query. And all we know that if you just take the user input and compose a dynamic query from that input without validating the input first, then this means your application will be vulnerable to SQL injection. The same principle applies when you, for example, also don't validate user input, and just like in our case here, so if you don't validate, someone can just include some JavaScript here in this text box, and once it's saved in the database and let's say brought again from the database to be shown on this list, then this JavaScript, once another user loads the page, it will be executed in his browser. So let's test this right now. So if I inject this code here, so if I save it and another user tries to click the link, then a JavaScript will execute, and all you can see here, it's a simple alert message in JavaScript, but you can do much more than that. So obviously, or this means the application is vulnerable to cross-site scripting and SQL injection. So this application, if I go back here to FortiDevSec, is already integrated into a DevOps pipeline. So if I go to my pipelines, so here is a pipeline for the application, and if I try to run it, and if I try to see the stages that are already there, I can see that there is the first stage, which provisions the infrastructure for the application. In this example, it's in Microsoft Azure. And the next stage will be building the application and finally deploying it to Azure App Service. So I'll not run the pipeline now because I run it already. So the infrastructure is ready, the application is built, and it's already deployed to App Service. So what if I want to integrate now security into this process? Basically, just like what my colleague Siddiq mentioned, security scan could be done after all of these stages were already performed. So it's in the end. But now I would like to integrate it in such a way that before each stage, I want to make sure that the outcomes of the stage itself are free from security vulnerabilities, or it complies with best practices in security for the outcomes or deliverables from that stage. So beginning with the infrastructure provisioning. Now, all you know that in the cloud, once you deploy your applications in the cloud, you are deploying your infrastructure as code. So for Azure, an example, I can use Azure Resource Manager templates to provision the code. So this is the templates that is used to provision the infrastructure here, which is basically an app service and an app service plan. So two objects here. But if you look closely at the properties of the object, in particular the app service. So if you scroll down here to site config in the app service, you will see that the state of FTP service is allowed, and this violates the security best practice in Azure. So if you check the best practices here, it tells you that you should allow only secure FTP or disable FTP completely if you are not planning to use it. So we need to scan this template first to see what security best practices are missing here. Now, because the main focus of this demo is FortiDevSec, and because FortiDevSec right now doesn't really support scanning infrastructure as code template, so briefly I will just demonstrate the idea to you with another tool called Sneak. Now, this tool, you can run it actually from the command line. So suppose that I uploaded my template here. So if I have a look at it, so here you can see it's the same file that I was in Azure DevSec. So if I use the tool to scan it, so I see scan and then the file name. It's not scan. So it tells me that I have 4 medium vulnerabilities and 1 high. So if I scroll up, I can see this is the high vulnerability, which the app service allows FTP deployments where it should be set to a secure FTP only or disabled. Now there are here 4 additional vulnerabilities here. So let's say I want to ignore these and focus only on this one. So the severity when it's high. So I can add here simply a command line switch about the severity threshold, and I'll set it to high. So when I do that, I would see only this one about FTP. So this is how I run it from the command line. So if I want to integrate it into the DevOps pipeline, let's go back to the pipeline. Okay, so let's edit the pipeline. So here is that stage. So I called it infrastructure as code scan. I'll uncomment these lines. So basically, it's about running the tool as a bash script. And here I have in Azure pipelines, as you know, you can, for example, for a task that it fails, you can have the choice to continue or to other tasks or stages, or terminate the execution of the pipeline. So here I'm ignoring it, but if I set this to true, and then if the tool finds a vulnerability here, it will the task will be considered as failed. So if I set this to true, the task will fail and the pipeline will stop. So what I'm going to do here is I'll make it true, so we can see that the pipeline will stop, and then we will fix this vulnerability and rerun the pipeline. So I leave this to true, save the pipeline, go back to my code, to the template, and for FTP I will say disabled. So edit, disabled, commit. Now, if I run the pipeline, so okay, let's run only this stage because we would like to see whether it will report an error or not. So let's run this. So basically this stage checks out the code from the repository, copies the file in question, and then as you can see, it passed. So if I click here, go into the details, so nothing was found. No vulnerabilities were found because I fixed it already. So this is infrastructure as code scanning. Now, For the remaining stages, which are the application build and deploy. So before I build, I need to make sure that the application code itself, the source code, is free from vulnerabilities. So I have to add a stage for static analysis. And I'll do this with FortiDevSec. So what I'm going to do is, first of all, I have to go to FortiDevSec itself, log into the portal, and create my application. So I have already created the application. And as you can see, no scans yet. I have just created it. But if I go back or click the application itself, I can see. Okay. So I need from this screen, I need the application ID and the organization ID. Why? Because if you remember from the slides, we mentioned that we have to add a file to the repository to configure FortiDevSec scanner, and it's called fdevsec YAML. So I have this file already. And all I have to do is enter my organization ID and application ID and the types of scanners that I would like to use. In my case here, I'm using the static analysis and dynamic analysis. And finally, I have to provide the URL where the application will be accessible. And here is an important note to consider. Because FortiDevSec scanners run as runs in your Azure DevOps agent as Docker containers. So here you have the choice to have your agent either in the cloud or maybe on your own environment on premise. So if you choose to have your agent on premise and you have also the choice to deploy the application on premise, so you don't need to use the cloud. And in this case, the testing itself, either static or dynamic, will be completely performed in your environment. Nothing goes to the cloud. Everything is in your environment. So for some customers, this may be an important thing to consider, that nothing goes to the cloud, either the source code or the application itself. So this fulfills this requirement. So this URL can be simply a private IP address or a private domain name in your environment. So once I create this file, then I am ready to edit the pipeline and add the static and dynamic analysis into the pipeline. So let's edit. I have added them already, just uncomment. So uncommitting the static analysis stage, and down there at the end, I'll uncomment the dynamic analysis stage. And as you can see, it's all about pulling the Docker image for the scanner from the Fortinet Docker registry, and then running the container and mounting the directory where the source code is checked out from the repository. So this is the current directory where the source code is checked out, and it's mounted within the container under a subdirectory called /scan. So when you do that, the container will have access to the source code and it will scan it. And obviously, on the agent, especially if you are running in the cloud, you have to clean up the container. Here Docker is run with the RM command line switch to remove the container after it exits the scanner. So let's run the pipeline. Validate first. It's okay. Save the pipeline and run it. So when we run, again, to save time, because some stages are already done, I'll right now focus on running. Okay, let's run it completely. No worries. So cancel and run. Okay. So first stage here, it's running this static security testing. So check the code. Now it's installing the FortiDevSec container. It was done quickly. So this stage is done. Now IAC scanning again for the template. It's okay. Provisioning. Now this shouldn't take time because the app service is already provisioned. Okay, provisioning done. Now building the application. Now basically here the build stage, because this is a PHP application which may have some dependencies, third-party libraries. So here it's using Docker Composer to download these dependencies and package them along with the application. Okay, so build complete. Now deploying to the app service. Again, deployment shouldn't take a long time, less than a minute usually. Okay, deployment is complete. And now it will perform the dynamic analysis. So the scanner will, from the base URL that I provided, will crawl the application and tries to find if it has any vulnerabilities which could be related to web server configuration. And we will see them once the stage completes and we check the FortiDevSec portal. So meanwhile it's running, let me confirm something. So let's confirm that the application actually is working. Yeah. And yeah, okay. So let's give it some time to complete the scan. Meanwhile, let's go to FortiDevSec again and go to the home page. Okay, so if I click the application, I can see that the static analysis, which detected PHP as the application source code, and it's completed, whereas the dynamic analysis is still running. So if I click the the vulnerabilities that are found in the static analysis, so the total are 18. So let's, using the filters, let's go to the category and check the SQL injection. So I have one vulnerability related to SQL injection. If I click it and scroll down a little bit, I can see that it's found on multiple files. So it was found in mail.php, index.php, tasks.php, and so on. So let's go to the source code. Actually, it should be reported on this file. I'm not sure why it didn't. Let me go back there. So it's the only one. Okay, it's reported on this file and additionally on these. So yeah, so on line 13, so if I go there, line 13, so basically this one. So what is happening here is, again, we are passing, or the application gets the task ID or the to-do ID from directly from a URL parameter, so get parameter, and constructing an SQL statement from it without validating the input. So in order to fix this, we all know that fixing SQL injection vulnerabilities can be simply done using prepared SQL statements and parameter binding. So this concept is can be implemented in any programming language. So particularly with PHP, let's edit this file and comment the vulnerable code, which is this, and uncomment the fixed code, which I prepared earlier. So basically, it's the same thing. I am changing the statement to put a placeholder for the parameter here, prepare the statement, and then binding the parameter to the statement where the parameter I'm getting it from the query string or the URL parameter, and then executing the statement. So this is how you fix it. So if I commit, and before we continue, I think the pipeline execution is complete. Yeah, it's done. So if I go back to FortiDevSec, I should see that the dynamic analysis is finished. Yeah, it's finished. Okay. So now we can run the pipeline again. So remember, for the static analysis, we have 18 vulnerabilities. I fixed one of them. So I'm expecting this to decrease. So yeah, let's run now to save time. Let's run only the static. No, I have actually to run the build, deploy, and or wait. Yeah, the static analysis is sufficient. So let's run this stage only. Going back to the pipeline, so run. So stages to run, only static analysis. Okay, it's done. Going back to FortiDevSec and refresh. Yeah, now they are 17 instead of 18. So if I go back, if I click here, go to the category SQL injection. Now I will not see, because this vulnerability applies to other files, I'll not see the file functions or functions PHP among them. So mail, and there is no function.php, which means that the vulnerability is resolved. Now, to track this vulnerability, as my colleague mentioned in the slide, you can set the status of the vulnerability here. So before I fix it, I was supposed to say that it's, or initially it's in a review, then confirmed. Then once before running the scan again, I can see it's fixed, and once I run it, it will disappear. So this is how, if there are multiple developers accessing the FortiDevSec portal, they can track which vulnerabilities were fixed and which were not. So back to the dashboard here. Now let me repeat the dynamic analysis for a reason. When I run the dynamic analysis, there were some entries that I created already, and during the scan, the scanning engine or the scanner itself tries to create more entries. So when you run the scans again, because how the application works, it will crawl all of these URLs. So you will see the number of vulnerabilities will increase over time after each run. So we may not be able to create a baseline here and compare. So I'll remove all of these. So instead of removing them manually, I have just included a script that will remove them. Okay, so this is a clean start. So let's retry the dynamic analysis and see the number of vulnerabilities. So I'll repeat it. So run again. Stages only dynamic analysis. So we will have a baseline to compare against. So to make sure that it's running, if I go back here, yeah, it's running, trying to experiment with some requests that may reveal vulnerabilities. So it should be done. Yeah, it's done. So going back here to FortiDevSec, refresh. Yeah, so it's discovered 30 vulnerabilities in the dynamic scan. So if I click it, okay, let's search for two categories. Okay, cookies without secure flag and cookies with no HTTP only flag. So here it's telling me about a cookie called, it should tell me the name of the cookie. Okay, anyway, I know the name of the cookie. So basically, it's the default PHP session ID cookies. If you go back to the code, and if you check any of these files, it's including or yeah, it's requiring or including the db.php file, which initializes the database connection, and also it initialized the session cookie with the session start function. So by default, when you call this session, the session start function, it tracks the session, or it creates the cookie on the client side to track the session. Now, by default, this cookie does not include those flags, the HTTP only and secure flags. So the way, if you would like to include them, you have to pass these parameters to the function. So cookie secure equals true, and cookie HTTP only also equals true. So fixing this vulnerability is all about enabling including these parameters. So this is how to fix it. Another one that we can see in FortiDevSec is yeah. So the leaking of the web server technologies or the backend technology that I am using through the X powered by HTTP header. So if I click this vulnerability, it's telling me that these files or on these URLs, the web server is returning the X powered by header and the value is PHP. So for me as a potential attacker, I know that this website or this application is running with PHP, and also because the app service plan, if I show you the app service plan here in Azure, so because I'm running Windows here, so you can see the operating system is Windows. So here I'm running basically IIS, and this Internet Information Server, IIS, is by default configured to host ASP.NET application. So even though my application is PHP, it's returning this header just because of the default settings of Azure App Service that is running on Windows. So basically I have to reconfigure the app service to remove those headers to avoid leaking this information. Now, unfortunately, removing this, the PHP header is a little bit complicated, so I'll not demonstrate it here, but for removing this, it's easy. All I need to do is go back to the source code tree, and I have to add the web config file and disable this functionality. So I have added this file, which says here, clear this header X powered by. And again, this will apply only to the ASP.NET header, not PHP. Disabling that header requires a more complicated process. So this file, once I add it to the repository, will disable this header. So it's already added, but I added it deliberately without an extension, so it will not be processed by Azure App Service. So if I correct the extension, the file extension, so edit, or sorry, rename. So I'll say web.config commit. Okay. Now I'll clear the database, and remember the number of vulnerabilities found in the dynamic scan. So the dynamic scan found like 30. Okay. Now clear the database. So truncate, cleared. Okay. So now I'll rerun the pipeline with build, deploy, and dynamic analysis stages. So run the pipeline again. Selecting my stages. So I'll not do static. I'll not scan the infrastructure code. Don't provision. So build, deploy, dynamic analysis. Before I do that, I think I didn't commit the db.php. Yeah, I didn't fix this. So comment this, uncomment this, commit, and run the pipeline. Okay, we are running out of time, so let's hope this completes within 5 minutes. Stages. So build, deploy, dynamic. Okay, so build and deployment is complete. Now dynamic scanning. Okay, let's make sure it's actually running. So I should see here some requests, or maybe a while. Yeah, it's running. Okay, seems to be complete. So let's refresh here. So it was 30, now it's 26, so it decreased. If I try now to search for that vulnerability again, which is related to powered by, I would see that the values found here are only related to PHP and no mentioning of ASP.NET header. I can still confirm this myself by looking at the headers returned by the web server. So opening the developer tools, doing request, checking the response headers, I can see now powered by PHP only. I cannot see the other header that what is about ASP.NET. So that means this reporting is correct. And again, if I go back there and try to look for the cookie thing, yeah, I don't see any vulnerability related to secure and HTTP only flags vulnerability. So this means this this vulnerability was fixed. And again, I can confirm it through the web server headers. So if I open developers tools again, do another request. Let's see the cookie. Yeah, PHP session ID. I should see here the secure flag. Yeah, this is the HTTP only flag and the secure flag. So this is also confirmed manually. So because we ran out of time and maybe you have some questions, so I'll stop here and listen to your questions. So any questions about the demo?